everyone, welcome to this webinar. Can you tell us in the chat if the sound is good? And then if you have any question, you can ask them during the webinar and my colleagues will answer them at the end of the session. So I leave you with my colleagues, Willy and Paul. They will present you this webinar.
Hello, this is Willy Mercier from ELA Innovation. So just in terms of introduction, I'm in charge of the sales activity for ELA Innovation, and the goal today is to present you one of our runner in terms of product from our MyBeacon portfolio, which is the BLUE Puck T EN12830, so the temperature sensor dedicated for the cold chain traceability. Just to check with my colleague Fanny. Fanny, just I don't have the slide in front of me. Okay, perfect. I hope that for everyone is okay. If you can see the first page of ELA Innovation with the title Industrial Wireless and Beacons and Sensor. If there is any problem, please be free to just send a quick chat to us on your chat box in order that we can check. So the idea, as I said, the idea today is to take the opportunity of this webinar to have an highlight on the BLUE Puck T EN12830. So to start, just for the people who do not know ELA Innovation, who we are, let's give you a few information, few figures. Fanny, give you me the possibility to change the slides.
Yeah. No, it's okay. You have it.
Okay. Because for the moment it doesn't look to work. I don't have any possibility to change. Sorry for that. So just to before getting the right page, and maybe you can change. Okay, perfect. So ELA Innovation. Sorry for the waited time. So ELA Innovation, we are a French manufacturer. The company has been created in 2000, so we are 20 years old. We are located in Montpellier in the south of France, and just for your information, from the beginning up to now, ELA Innovation has been dedicated to the development and sales of wireless beacon and wireless sensor. Historically, it was with the active RFID technology, but for a few years, we have been focused on the 2.4 gigahertz product portfolio, especially with the standard BLE. But if you have a look on our website, you will be able to see that in addition of the standard BLE, we have also Y-Pass mesh portfolio and Coupa with the angle of arrival protocol. And the most recent product family is based upon LoRa technology. So the idea is we would like to be more and more a reference as wireless beacon and sensor manufacturer, or whatever the technology. To do that, we are a team of 30 members, mainly in the technical. I would say technical teams and R&D teams. The R&D is really and the innovation is really the DNA of ELA Innovation, since 40% of our revenue is dedicated to this part with the team and with all the advanced that we have to do in order to offer you the widest product portfolio. Since we are on the IoT market, and especially on the industrial IoT markets, we have the chance to be in very strong and sustainable market with a significant growth, and that's why we have the chance to show this 270% growth over the six past years, so roughly 45 to 50% per year. And the international sales correspond to 20%, 25% of our revenue. Last year it was 16%, between 16 and 17%. So it's clearly a strong signal about our capacity to provide and offer our products not only for the French market, but for the European market, but also for Middle East and Africa and North America, where ELA people are now located. And the last point is the fact that up to now we have been able to deploy up to 500,000 units with a strong acceleration over the past years, thanks to the high demand coming from the market for the industrial IoT devices. So this is very short presentation of ELA innovation. The next slide, I will say, will be ready to present you what is this BLUE Puck T EN12830, this temperature sensor. But before going in details with this sensor, we thought that it could be a good opportunity to, I will say, clarify or at least to provide information about the standards themselves. Of course, the EN12830, but also the EN13486, which is associated to the first one, but which needs to be really correctly understood according to the goals of those two standards. After that, we will present you the key features or the key characteristics of the BLUE Puck T EN12830, especially on the software features, which is a very critical part according to the latest edition of the EN12830, and especially we will have a focus on the format of the frame which is transmitted, log and transmitted. How secure is this BLUE Puck T EN12830 in terms of data transmission? We will have a few words related to the calibration, which is a recurring question that we have from our client. And the last part is not really based upon the EN12830, but more for our clients as integrator. Just a quick word about the mounting. Okay, so now just before starting on the product itself, let's have a look on the EN12830. So this EN12830, what you have to take into account is a European standard, of course, but the most important thing I would say that it's this certification that we passed is based upon the August 2018 edition, and this is quite important when you compare with the previous edition, which was dated on 1999. So you can imagine that there has been a big difference in terms of market and wireless sensor between 1999 and 2018. And the 2018 edition is already dedicated for the wireless object, the wireless temperature sensor, and we will see how that could be really helpful for any solution provider or any system integrator to use a temperature sensor which is certified with this latest edition. So this standard is dedicated for temperature recorder for thermosensitive products, and it's also quite important to take into account that it's not only for food, it's for any product, any food, anything which is thermosensitive. So by this way, it means that the application scope is quite wide, and any user has to double check if, according to the sector of the activity, according to the products or the foods which needs to be monitored, if this EN12X30 has to be applied. So after having said that, we can nevertheless say that the main market today is for the transport and logistics, and the main type or the main category of products based upon our position as a manufacturer of wireless sensor is for the foods, for the frozen, the deep frozen, perishable foods, but also for the medical product, and so the medical sector with any type of medical category. So this is the EN12X30. If we look at the next slide, yes, the first question that we have got from our client from the moment that we introduced the BLUE Puck T EN1230, which was in September last year, is how can we be sure that this temperature recorder is already certified by with the EN12X30 standards. The first, and I would say the most important thing, is to get the certificate, a conformity which has to be provided by the manufacturer. So in our case, by ELA Innovation. So we provide this certificate on demand, and this certificate has been released by a laboratory which is accredited for, I would say, by what we call in France is COFRAC, which is more or less the body lab which has the homologation to pass this type of certification. Okay, so it has to be a certificate from this type of laboratory with a stamp in order to prove that this recorder is really certified with these standards. In addition to that, in France, I don't know for all the European countries, but we have our the Minister of Agriculture provide on the website an updated list of all the temperature recorder which has this standards, in order to have this list of products on the market in a central point managed by the Ministry of Agriculture. The next slide is just to try to avoid confusion between the EN12X30 and the 13486 standards, because for the, I would say, the cold chain traceability markets, these two standards are mandatory. The first one, the EN12X30, is under the responsibility of the manufacturer. The second one, the EN12X486, is under the responsibility of the user, and especially normally the end user, like the transport carrier or the logistic company and so on. This EN13486 standards is dedicated for the periodic verification for the temperature recorder in order to check if the temperature provided by the sensor are, I would say, compliant or correct compared to a calibrated device. So this standard is also managed or under the control of accredited standardization laboratory, what we call COFRAC in France, but there could be any labs for any European country. So they normally offer this type of service in order to measure and compare and provide a report, a test report, in order to prove that this the sensor itself has been checked, has been verified. You have to take into account, you or your clients, that this batch of tests takes into account that temperatures used in your sector of activity, depending on the type of thermosensitive goods. and also the precision or the accuracy class, which could be class 1, class 2, class 0.5, which is also depending of the type of the food. Okay, so or the type of the product. So this is something that you have to take either with the standard itself or through the laboratory, who can help you on these points. Okay, and the last point, but not the least, is how often the sensor has to be verified. It's also depending on the effector activity, but generally it's in the major of the cases is every year or at least every 2 years. Okay, so please take into account these two standards on between the EN12830 and EN13486. And if you need any information, we wrote an article on our blog, which is quite complete, quite exhaustive. And you can have this link, and you can go also on our website in order to get more information about that. After having said that, let's go to the BLUE Puck T EN12830 specifically, and just to give you the key points of this this temperature sensor. So the first, as I said, the first point is the fact that this BLUE Puck T is certified with the latest edition, so which has been released in August 2018. And the really good thing for that is the fact that this product is, I would say, 100% autonomous in terms of compliance with these standards. And the opposite of that is the second approach will be to certify all the system, taking into account the reading device and the application, which was already the case for the previous standards. But with the new edition, we have the possibility to certify only the sensor itself. It's a bit more complex in terms of processing, in terms of, I would say, timestamping, integrity of the data, and so on. But at the moment that everything has been checked, tested, and certified, that means you have the possibility to use it without doing anything else in your system to be compliant with these standards. So that should facilitate all the markets for the cold sensor stability to be able to provide a monitoring solution for the thermosensitive products. The second key point is like all our sensor on the My Beacon range on the Bluetooth low energy product portfolio, this sensor has the possibility to store up to 4,000 temperature value, which is also timestamp, and this is quite important for to be compliant with these standards. The second point, which is clearly one of the key points for our wireless beacon and sensor, not only for this BLUE Puck T, is the life cycle that we can offer with this BLUE Puck T EN12830. So I would say for industrial purposes, we have the possibility to offer a temperature sensor which will last up to 7 years, despite of this very, I would say, recurrent transmission and information. So the advertising frame, that means the real-time information for the temperature information, will be every 3 seconds. The logs will be every 10 seconds. And by downloading every day 4,000 value, we have the possibility to offer a BLUE Puck T, which will last more than 7 years. So this is for us a key point in order that it gives the possibility to our client to get rid of this question of the battery and the replacement of the battery. Of course, after the 7 years, but it's a quite long period according to the industrial market. The next point for this BLUE Puck T EN12830 and really dedicated to this version is the fact that you can program our sensor with the NFC chipset. This is the same case for all our beacons and all our sensors. But for this BLUE Puck T EN12830, the NFC is secure in order to prevent anyone to be able to change the settings of the sensor. And in addition of this first level of secure way, we have also the possibility to download all the value up to 4,000 value with a secure connected mode. Okay, so normally in order to provide or to get, not to provide, but to get the downloaded or the store value, you have to be in connected mode. In order to be compliant with the EN12830 2018, we had to develop this secure link in order to be sure about the integrity and the information. Next slide is to provide you also basic key points of the BLUE Puck T, and just to come back on the basics of our generation of BLE beacon and sensor, and especially for the BLUE Puck family. The BLUE Puck family has the power to transmit their frame up to 500 meters in open field. Of course, we are talking about open field, which is a dream in our industrial application. But by this way, even if we are on 4.2 generation of the BLE chipset, it means that according to the design of our internal antenna, we have the possibility to transmit at the maximum at this distance. And it gives some, I would say, give a margin of security for any integration in industrial environment. The other point, of course, is you can adjust the transmission power. The life cycle that I just gave to you on the previous slide, about 7 years or 7.5 years, was in full power transmission power at 4 dB. But of course, you can limit that if you want for any reason, or at least to optimize a bit the battery life cycle. So for the BLUE Puck T, please take into account that the temperature range is between -30 to 85 degrees, and the class of our BLUE Puck T EN12830 is a class 1. That means plus or minus 1 degree. We have the accuracy, which is plus or minus 0.5 degree from minus 25 degree up to plus 85, and it's really on the lowest negative temperature that we drop to the class 1. So this is just indicated. We thought that it could be helpful also to remind you the size of the BLUE Puck T, because it's quite compact. Maybe this is not easy to, if you never use our BLUE Puck, maybe you may have a different feeling about its size. So it's only, let's say, less than 6 centimeters diameter for the base, and the height of 2 centimeters. Okay, the housing itself is quite well designed and robust, and this is an IP65 housing. But please take into account that I would say we take the opportunity of this webinar also to inform you that our housing will change, and especially for this EN12830 BLUE Puck T, we will get an IP68 housing, quite similar, but without the Gore-Tex cap that we have for the moment, while ensuring this standard compliance. The two last point, but not the least, also are the fact that everything can be programmed through the NFC chipset with our device manager, which is our configuration software. And this software exists on the PC version, but also on the Android version that you can find on the Google Play. And we have also the device manager connector, which is another software which has been developed by our team, a free software that you can find for the moment on the Windows Store. And by this way, you have this possibility to test the transmission, to test also the fact to download the value in order to be able to start the integration of the data for your temperature monitoring solution. So I hope that these two past slides were quite clear in order to show the high point or the main characteristic, the main key point for the BLUE Puck T EN12830. And now I'll let Paul, my colleague, to present you the technical, the main technical software features.
Thank you, Willy. Hello, everybody. I'm Paul. I'm the manager of the research and development of ELA Innovation. So, as Willy has presented before, we provide and we distribute compatible software with this device. However, it's always feasible to integrate our device within custom-made software, and the functionality will be basically the same. But in order to stay compliant with the EN12830 standard, the device, in the firmware of the device, there are few features that are imposed in order to comply with the standard. So these features are summed up with this bullet point. So it's the data logger frame format, the securization of the transmission and the control of the device, and the calibration and the fact that the information about the calibration remains stored in the sensor. Regarding the data archiving, so to understand how the sensor works, you have to understand that we can interact in two ways, through the NFC interface as a main configurator, and the second way to interact is through the Bluetooth Low Energy interface, which has a limited feature compared to the NFC one. So all those data achieving can be controlled through the BLE interface, apart from the configuration of the period of logging, which is configured once through the NFC interface. So the Bluetooth interface allows to define starting time for the logging of the temperature, and send the current time and date to the device in order to timestamp the first measure and increment the following measure. The Bluetooth interface allows also to read the measurements. It could be once every when the measurements are done, and it's only one measurement, or it could be all the data stored in the data logger. This could be up to 4,000 values. And it's sliding data. So if the data logger is more than full, it's stored only the 4,000 most recent value. As I said, the period of data logging is configured once with the NFC interface, and the tag can still provide all its data stored in the logger through the BLE interface. So the format of the interface, when the command of reading the data logger of the device is sent from the BLE interface, is composed of three parts: a header, in which you'll find different information about the tag itself, firmware version, MAC address, a tag's name, unit of measurement, and the log start date. You'll find also information on the calibration of the sensor. I'll come back on this point later on. The second part of the data includes all the timestamp measurement according to the standard. So, which is the measurement date, the exact time of measurement, the GMT zone, and the temperature value in Celsius. Then there's the last part of the header, which is dedicated to code correction, error detection algorithm, and I'll come back also on this point later on. So the standard EN12830 imposes a certain level of security on the tag. So it mustn't be possible to change the behavior of the tag once the log is started, and it the data transmitted should not be tampered by external individual. We have another level of securities, which is that there's a password that give access to the NFC interface for parameterization of the tag. So once you have given this password, you can access to the configuration panel, and you'll have to set another password composed by 10 characters, which has to be sent for each time a BLE command or BLE request is sent to the tag through the BLE interface. So if for example, at the end of the day, you want to download the whole data log, you have to send, you can send to the tag the reading request of the data log through the BLE interface, and you'll have necessarily to enter a password for that. The second level of security, as I said, allows us to guarantee that there won't be any problem within the transmission pathway between the tag and the interface of which the user is using to look at the data. And this error detection is based on the CRC, so cyclic redundancy check algorithm, which consists in defining a characteristic footprint of the transmitted data, sending the data and the footprint together, then recomputing the footprint and compare the recomputed footprint with the received footprint. And the two should be equal, otherwise the problem in the transmission has happened. The last feature that is specific to the norm and implemented in our device is the calibration. So the temperature sensor in the device has a certain typical accuracy, which can be modified or improved with polynomial fit during the calibration phase. So this consists of measuring at least 3 temperature within controlled environments, and defining with least square fitting standard procedure 3 polynomial coefficient that can be stored within the tag and used by the tag in order to correct the measure read directly from the temperature sensor and store corrected data only. This coefficient can be configured through the NFC interface, and the corrected value can be broadcasted on the through advertising normal mode, and can be stored in the data log. Still on the calibration, it's possible to save within the tag the different data points used for the calibration, and not enable the automatic correction of the measurement, so that you might be able to download the actual value measured by our sensors and correct later on the value according to the proper calibration point. Of course, the two features are not exclusive, so you can either use the correction and not store the calibration data. You can store the real value from the sensor and store the calibration data, or you can store the corrected data and the calibration points. So now I will give back the speech to my colleague Willy, that's going to present you some more information about how to handle physically the device.
Thanks, Paul. Thanks for this technical explanation and technical information about the temperature sensor. This last part of the this presentation is just to highlight how the BLUE Puck T EN12830, but globally our BLUE Puck products could be mounted. So this is the recurring question that we have got from our client system integrator. So currently there are two ways of mounting the BLUE Puck T EN12830. The first one, which is more and more used, is to use an adhesive or to glue, I would say, the sensor. So it could be I would say by the integrator himself, and without requesting anything from us. But if needed, we can offer the puck sticker, which is an adhesive double-face sticker, circular shape. And this is already an ultra powerful adhesive because this is a 3M brand, and the adhesive itself is the PT 1100 or 1100 to be precise, and it's really powerful because it's used to fix to mount our puck even for outdoor condition. And just for information, this adhesive has been used to mount our puck on containers which are transported outside every day, and so it's really powerful. In addition of that, we will be able to provide from the same date as the one for the new BLUE Puck T EN12830 with the IP68 waterproof. So from April 2020, we have designed a new support, a new order, which is named the puck holder sticker. On what you will be able to slide the BLUE Puck T EN12830, and this puck holder can be mounted with the adhesive double phase sticker, of course, but also by using screw or by using the clamp. All of them won't be visible after having slided the BLUE Puck T on the in the order. And in order to maintain the BLUE Puck T inside the order, there is a specific tamper-proof locking screw that you can see on the 3D redrawing that we have inserted on the slide. So it was just an information, a quick information about this mounting. I would say this mounting question that you may have for the BLUE Puck T EN12830, even if it's not dedicated for this EN12830, but for all the BLUE Puck. So to summarize, if you need any added information, please take into account that on our website, you will find all the documentation related to the BLUE Puck T EN12830. Of course, the product data sheet, but you will have also the Bluetooth user guide, the Bluetooth low energy frame specification for all our mild beacon range, so for the identification beacons and also the sensor. We established a dedicated application node for this product, and all the information, technical information that Paul presented today are also documented in this application, not in the exhaustive standpoint, in order to be to provide you everything which is needed for the efficient integration. And the device manager that we were talking about in the introduction for the configuration of the BLUE Puck T, but also the device manager connector can be downloaded on our website, and you can find, of course, the declaration of conformity. So everything is available, can be downloaded from our website. If you have any question, of course, you can contact us at sales@airlineinnovation.com, and we will provide you the answer through the sales team. And now I would say, after talk a lot, it's maybe your turn to send us any question on the chat box. If we have time, so let's say that we plan to close at 45, so we have a few minutes, and of course we will answer you after this webinar. If there are other questions, we will provide you an answer by email. Okay, so on the question, let us check the question. There is a first question, which is, will you receive the presentation? Of course, after this webinar, all the attendees will receive an email with a link to download the webinar presentation. Okay, there is a question regarding the I would say a few questions about the temperature range. So just to clarify, the temperature range of the BLUE Puck EN12830 has been certified from -30 to +85. So it's really from this negative temperature that the certification has started. Okay. Can we start and stop the sensor? No. No, and yes and no. Yes, of course, you can stop it and start it. So activate and deactivate. That could be done through the NFC chipset. You can do it with an NFC reader or with any. There is a sound. Sorry. So maybe can be put on mute. So you can activate and deactivate through the NFC chipset, so either with the NFC reader or with the mobile device, like a smartphone, if the smartphone has this NFC chipset. is there a difference between Bluetooth and NFC security? Maybe Paul, you can answer to this technical question regarding the TQA.
So the difference between the security level between the NFC and the Bluetooth. So both of them are access is protected by a password. In order to, so speaking for the the configuration software that Ella is distributing, the password for the NFC interface is required only once in order to connect to the tag through the NFC interface. When the password is passed and the tag has recognized that it's a legit password, then you can interact with the tag through the NFC interface. With the BLE interface, it's a little bit different because you have to pass the password each time you want to send a command or request to the tag. And that password is given, is broadcasted to the BLE just after the command definition and the different parameter of that command. In that way, you can define two levels of users, a kind of super user that will define main operating parameter of the tag, such as its logging frequency or its calibration behavior. And the second level will be the generic user. So people that want to have access to the data log, but cannot change the behavioral parameter of the tag.
Okay, so it's 347. I think that we have to close and to I would say I would like to thank all of you for the participation. I hope that this webinar, which was already dedicating on one product, provide you interesting information. We remain at your disposal, of course, to for any added question. Please take into account that ELA Innovation will participate to the Mobile World Congress in 2 weeks at Barcelona. And if you, I would say, remain tuned on any post, we will organize a new webinar probably in the middle of March. Okay, and probably also dedicated for the asset tracking, especially with one of the other technologies than the BLE standards. Okay, thanks a lot. Have a nice day and talk to you soon. Bye bye.